Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about part 48, how to configuration hardware between PLC GE and PLC S7300 by using the Profibus module. So here is the previous project that we already learned about how to create the Profinet I/O of PLC GE. Yes, Profinet 1, Profinet 2, and I will use one more for Profinet number 3 for config the Profibus Master from PLC GE. Yes, that link with Profinet I/O. Link to the PLC S7-300, and I will link data from PLC GE to PLC S7-300 and link data from PLC S7-300 to PLC GE. Okay, so in this section I will use two software. The first one is Proficy Machine Edition and the second one is Schematic Manager. Okay, so before go to our software, I would like to explain a little bit about the concept. The concept is we would like to send the data, yes, communication data between PLC S7300 with PLC GE by using this concept. Okay, and I have Profibus Master of PLC GE model IC200BE AM003. It is the Profibus Master, and for PLC S7300 it is the Profibus Slave. Okay, I will show step by step about how to configure the Profibus Master of PLC PLC GE and Profibus Slave for PLC S7300. Okay, so let's go. First we will configure the Profinet for this I/O and this I/O, and the second we will create one more for Profinet I/O and then connect with Profibus Master to the Profibus Slave of PLC S7-300. Okay, so let's go. Okay, so first open Proficy Machine Edition. Okay, I will start from config the first Profinet, the second Profinet, and the third Profinet for Profibus Slave. Okay, so I hope this video is maybe long a little bit, but no problem. I will explain step by step about how to create. Okay, so right click and then create a new project. Example, I will put PLC S7 and then create the empty project. And I will add the target, yes, GE Intelligent Platform Controller, and I will use R3i, yes, to match with my hardware. And here I can rename the target name, example S7. Okay, S7 PLC. and then go to the enable the Profinet, right? LAN for LAN 2 of CPE. So let's go to LAN 2 and then enable the LAN 2 for Profinet, and then I will configure for power supply of my rack. So right now I use PSD040, and for CPE I will use slot number 1. So drag and drop to slot number 1. And then I will configure the LAN port for communication with my PC for online download and upload. So let me choose true for variable mode, and then go to configuration, and here I will use 192.168.0.100, the same as previous project. Subnet MAC 255.255.255.0, and for terminal I will map with the variable, example CPE ETM 8-bit, right, for status address. Okay, 80-bit. And then for target address I will put 192.168.0.100, because the previous video we already learned it. So maybe I can ping. Let me test. Okay, we can ping. It means that we can communication between our PC to the CPU, because right now I already turned on the power and connected the LAN cable from my PC to the CPE. Okay, so let's go to the Profinet controller configuration. Yes, the first one we need to configure the variable mode to true. And for the LAN 2 we need to put the IP address to be not the same with the LAN 1, right? So the IP address of LAN 2 I will put example 192.168.100.1. yes, and should be changed this one also .100.1 to 100.254. okay, and click create, and then we will insert the Profinet scanner, right? Let's save the project first. So to create the Profinet scanner, yes, here Profinet scanner number 1 here, DI and AO, yes, and AI and AO, DI and DO, yes. So I will create the module number 1 of PNS. So let's go to add, right click, add IO device, and then go to PNS 001, the same as the catalog order number. Okay, after that let's go here and then choose the create, and the IP address will rank automatically, yes, and the device name will create also. Example I will put this one to PNS1, so this one will change automatically. Let's see here. Okay, and the IP address is 192.168.100.2. okay, for module number 1, and we need to create the Okay, this one. We will create the power supply, right? Add the power supply, but before add the power supply, let's go to variable mode and choose choose true, and go to configuration, and we need to map the variable, right? Example, PNS1 in, it means that input, and we use 32 bits for input status, and for output also the same. So PNS1 underscore out, and we need 32 bits also for output status. Okay, and then we need to add power supply, right? One more. Okay, and then we will add the IO, right? The first one is DI, right? DI here. So to add the DI, let's click here and then change module list and go to the discrete input module and choose the module that match with the hardware. Yes, and one more for digital output. Yes, and then click OK and save the project. So for digital input, it will start from %I1. Digital output, it will start from %Q number 1. Okay, so that's all for module number 1. And the next we will create the module number 2, right? Or we can create the module number 3, but for the step we can create module number 2 first. So let's go to add IO devices and then go to PNS001. And this one we can change to module number 2. Yes, it will change automatically, right? If we put like this, and we can create. And the same procedure, we can go to add the power supply. Sorry, can add power supply, right? Change this one to true first, and then go to configuration, and we can map the variable PNS2 underscore in 32 also, and one more PNS2 underscore out 32 also. Yes, add one more power supply, and then we need to add the IO, right, for analog input and analog output. Okay, so let's right click and then change module list and then go to analog input. Right now I use ALG264, so drag and drop here, and then one more for analog output, ALG331, and then for analog input we need to change the sub module. Right now I will use 4 to 20 milliamps, so drag and drop. And for analog input, it will start from %AI1, and analog output, it will start from %AQ1. Okay, it is for channel. So that's all for module number 2, and the next step we will create for Profibus, right? Profibus Master here for link to the PLC S7-300. So let's go to create the module number 3. So right click here, I will minimize this one. Right click here and then add idle devices and go to PNS001 again. Yeah, and then click OK. And we can change this one to number 3, right? PNS number 3. Sorry, I will copy this one. PNS1, PNS2, right? And then change to PNS3. Yes, like this. And then I will create. So the IP address of this module is 192.168.100.4. And let's go here and then choose true, the same as procedure that we already created with module number 1 and number 2. So this module we do the same procedure. So example PNS3 in 32 bits, and for out PNS3 underscore out 32 bits also. Okay, and then we can add more for power supply. So right click and then change okay, right click here and then change this one and then insert one more power supply, and we need to add the Profibus Master, right? Okay, this one IC 200 BE AM003 Profibus Master. So to create Profibus Master, let's right click and then change module list, and let's go to bus controller here, and we will see the BEM003 Profibus Master. Okay, so drag and drop here to the list and then click OK, and we can change the data address this one to automatically. Yes, just click auto. Yes, automatic. And then we will add the slave, right? Slave file for the PLC S7-300. Yes, here. So in this step we need to use the GSD file. Yes, here. Otherwise we cannot use it. So we need to use this file. Yes, use this file, GSD file. So let me insert the Profibus Slave. So right click here and then add slave, and then choose the model address, model number of PLC S7-300. If we don't have this file, we can have this, choose have this, and then to browse the file that I already show here. Yes, from this file. So let's add again, add slave, and then choose the file. Yeah, this one for Profibus Slave. Yes, and then we need to put the address that we want, Example, in this step, I will choose address number 5. Yes. We can choose another address that we want. Yes. And here I can add, yes, first general ID, second general ID, and third general ID. And the next we can add the data, yeah, that we want to send to PLC GE. Yes. Example, master I, slave Q, 8 byte. Yes, we can choose this one. And one more for feedback. Yes. Or control to PLC GE, I can use the master Q. It means that PLC GE is output and PLC S7-300 300 is slave. Yes. So we can choose like this and click OK. We will got like this. Okay, so the address will start from %I161 and %Q it should be 49. Yes. Okay. So we can download this project to the PLC GE. Yes. So let's save the project and then connect and then download. Okay, I will stop CPU first because we must download the hardware configuration. Okay, let's see what is the error. I/O memory without. Okay, so we need to put the memory of CPU. Okay, like this. Otherwise, we cannot download. Okay, and here we can increase also. Example 500, and then we can download again. Try to download again. Okay. After download, we will set the name of the Profinet again, one by one. Okay, so I will start the CPU. Yes. I will show like this, easy to see the status. Okay, so we can minimize. Okay, right now the CPU is running. Yes. So we need to create one by one for the Profinet, right? We can change the name and IP address follow this step. Yes. Okay. So the first one, I will change the IP address of PNS number 1 to 192.168.100.2. Yes. So let me scan to see or not. Let's scan. Let's go to tool and utility and then choose this one and choose the LAN and then scan. If we cannot scan, we can connect the LAN cable directly to the PNS. Okay, right now we cannot scan, right? We can see only one for PLC S7300 because right now I already connected the LAN cable to the switch. So let me disconnect and connect to the PNS directly to set the IP address and name. So the first one, let me connect to the PNS 001. So number 1. Okay, let's scan again. Let me show. Right now I already connected the LAN cable from my PC to the PNS 001, number 1. Yes, let's see here. I already connected the LAN cable to this port. Yes, and the status is not yet connected, right? So let's scan together. Go to the utility and then click this one and then scan. When scan, let's see the bling for LED. So right now we detect, yes, it detect one for this PNS. So let's check, the name should be like this. So I will copy, yeah, Control C, and then double click here, then change the name to this one, and the IP address is correct, so we don't change. So set only name, okay, and then click exit. So we scan again. To make sure that we change is correct, yes. So let me show again. So I will disconnect LAN cable from this module and then connect this cable from the CPE, yes, to this module. Okay. And then let's see the status now is connected, right here. Okay, connected. So let's go to module number 2 here. So I will disconnect the existing cable. Yes. And then connect the PC cable to this module. And then let's scan again. Okay, we will detect one, and let's check the name should be like this. Copy and then paste. So paste here. Okay, no need to change anything because the IP address and name is already set. Okay. So I will connect the LAN cable from the CPE. Yes. So let's see right now the status is connect also. Yes. So we have the last one for Profibus, right? So let me disconnect cable from the computer and then connect to this port for set the IP and name also. Let's see, right now I already connect the LAN cable from my PC to this node, and then let's click here and then refresh again. Okay. Okay. The IP address is wrong, right? So we need to go to this module and then copy, right? Copy and then paste here. And the IP address should be changed to 4, right? So 4. Set the IP. Set the name. Okay, and then exit, and then let's confirm again for scan. It will change to 4 and this one change to 3, right? Okay. So we successfully change and then exit, and we can disconnect the LAN cable from this module and then connect to our computer back, because we already set the name and IP address. And then let's connect the LAN cable from the node number 1 to this module. Okay, I will connect. And then wait a moment, it will connect, yes, if the communication is okay. So we can go online, our project. Okay, and then let's go to create the project for PLC S7-300, right? Forgot and send data to PLC GE. Okay, then create a new project, example link to GE. Yes, link to GE. And create a new project, example link to GE, and then choose the folder that we already created on desktop, and insert the new station for PLC schematic S7-300 station, right? We can write link to GE, yes. And then we can insert the rack. Okay, insert the new rack and choose the CPU. Right now I will use CPU 314C 2PN/DP to match with my hardware, right? Okay. And here is very important, yes, for setting. The first one is IP address. We can connect with our PC to download and upload the project. And the second one, we need to put the Profibus for communication with the PLC GE, right? So we need to put the Profibus. So let's click here and then click new and click OK. Sorry, we can delete first and then click OK first. Yeah. And then go to setting here, right? Sorry. Go to MPI-DP, double click. And then choose this one to Profibus. And here is the address that we need to put, yes. The match with the address of PLC GE that we already put here. So the address is 5. Let's see here, 5. Yes, station 5. So here we can choose the station 5, address 5 also. Yes. And create the new for Profibus and choose the 1.5 megabyte per sec and DP, and we can click OK and go to property, yeah, to check and click OK. And then go to address, yeah, it is the default, yeah. For this tab operating mode, we can setting to DP Slave, and the address is default, yes, use default. And for configuration, we can create the data that want to send and want to receive from PLC GE, right? So the data is should be made with this one. Example, here is the master from PLC GE is input slave, right? Because master slave shoe. Sorry, master I choose slave. It means that master is input and slave is output, right? So we need to create the output first for this step, right? Of PLC S7-300. So let's choose new, and it is the output, right? Because the GE is input, so slave is output. Okay. So let's select output, and the address should be automatically created. So the length is very important. So the length of PLC GE is 8 byte, right? So here we can choose 8 byte, and consistency we should choose all. Okay, and then choose OK. And we need to add one more, right, for this data, because we have two data that send and receive from PLC GE. So the PLC S7-300 should be add 2 also. Okay, so master Q slave I, right? So slave I means that input and 8 byte also, and choose all. Okay, so output it will start from Q 0.0 and I 0.0. Okay, 8 byte. So click OK and then save the project. And we need to download the project to PLC S7-300, right? So let's click OK, download. Wait a moment for detect the CPU. Right now I already connect 192.168.0.1 for CPU of PLC S7-300. So we can ping Then wait a moment for detach. It will automatically detach. Oh, I forgot insert one more for analog. Yeah, the same as the previous video. So let me insert one more. Otherwise it will error system fault if we download. So it is the existing project. So let me add one more for analog input. 7KF02. Yes. Input type I will change to resistance for channel number 1, and for channel number 2 is 0 to 10 volt, and this one 4Y 2Y transmitter we already learned in the previous video. So let's save again and then download again. Okay. After that, start the CPU. Yes. Then we need to create the logic, right? So right now we will send the command from the output from PLC GE, right? Example Q %Q49. Yes. So let's go to create the logic. Or we can test directly. Okay, let me test directly first before create the logic. To test the address directly, let's go to reference table. And create the new table. Example link to S7. Double click here. And then it will start from %Q49, right? For link data to PLC S7-300. So example %Q49. Okay, so we can test by forcing the signal from PLC GE and let online the PLC S7300 to check. Example, I will check with the address. So it will start from, okay, I will zoom like this. Easy to understand, yes. Okay. Like this. And PLC S7300. Let's see the hardware configuration again for the address. So the address for input is I0.0, right? So we will start from I0.0. Yes. I0.1. And then we can online, right? So if I force signal from GE, let's see the input is turned on PLC S7 300, right? Okay. Let me arrange a little bit for easy to see. So if I force signal, point number 2, yes, until I 0.2, I0.3, I0.4. Okay, this one I0.3. Yeah, we can test only 5 bits, so we will know. Okay, I will force more for this signal. Bit number 3, yes, turn on. Bit number 4, bit number 5, yes, it will turn on. So if we would like to force the signal from PLC S7-300 to PLC GE, we can force also, because I will show the network is communication correctly, right? Let's see the communication is work correctly. Yes, for Profibus Master and Profibus Slave. Yeah, and the CPU is running. Yes. And then we can for the signal. So let me check the input, right, from PLC GE is start from input board. So master in, right? So input 161, yes. So here we can choose option I 161. And for the output of PLC S7300, start from address. What is the address? Q 0.0, right? Okay, so I can write Q 0.0. Sorry, here. Q 0.1, Q 0.2. Yes, example Q 0.3, and then we can for the signal also. I will write through. Let's see the bit of PLC S7300. Sorry, PLC GE is turned on. This one also true is turned on. One more. True is turned on. One more. And true is turned on. One more. Okay. So it worked correctly. So the next step we will create the logic, yes, for start and stop from the PLC GE, and then show the status on the PLC S7300. Okay. So right now I will remove this one first. Set to 0, set to 0, and this one I will set to false. It false also, right? Okay, good. So I will create the new logic for control the PLC S7300, and then let me show the status when we push the button. Okay, I will offline first and then create the sample logic for start and stop the motor control to PLC S7300. So let's go to main program. Yes. I will create the sample example command. control motor to PLC S7-300. Okay, and I will choose NC. It is for stop. NO, it is for start, and motor, it is coil, right? Motor 1, yes, and I will hold the signal, so NO, and then hold the signal for motor number 1. Okay, and here I can choose the person I, yes. Example, the slot number 1 of this module, it start from person I1, right? Here. So here I can choose person I1 for start. And stop is person I2. And for motor is person Q that link to the PLC S7-300, right? So master Q, slave I, right? So here should be master I, slave Q. So person Q 49, right? Okay. So I will choose person Q 49. Okay. And then I will show the signal that feedback from the PLC S7-300, right? So we can command show the signal feedback from PLC S7-300. So this one should be NO, right? Example, feedback from PLC 300 is sent from PLC to person I, right? So it will start from person I 161, right? Okay. So example, S7-300 1. Okay, so we can choose the person I, but before choose, I will create one more variable. Example, receive bit 1. Example, I will show the status. Example, show on the simplicity as S7-300 bit 1. Yes. So this one should be person I, right? 161. Yes. And this one should be person M. Example, person M. So we can download the logic to the PLC. After this one, I will create the SCADA, yes, and WinCC to simulation, yes. So right now, if I push button, yes, I will show the status of button. If I push button start, let's see, the motor is turned on. Push the button stop, is turned off. Yes. Start again. It's turned on. Okay. And then we can go to PLC S7-300 to create the logic also. Yes. So this one we can command got data from PLC GE. Example bit 1, right? Bit 1 is I 0.0, right? Right now it is on because the motor is turned on. Yes. Here is on. Yes. So we can write like this, I 0.0, and then turn on, example, turn on Q. Let's see the Q of hardware. It will start from this one, right? Output 136.0, right? So Q 136.0. Okay. And then if this one turn on, it will feed back to the PLC GE, right? So let me insert one more. So to feed back to PLC GE, let's choose the Q 0.0, right? So Q 0.0, okay. So we can save and then download the logic to the PLC, and we can online, yes. So the motor is turned on, yes. Let's see here. Okay. I will minimize this one first. So if I push button stop, okay, motor will stop. Push on again, motor will on again, okay. And then we can create the WinCC flexible to show the status from PLC GE and use the Proficy Workbench to create the SCADA. Yes. The first one, I will create the SCADA first. Okay. So let's go to Workbench. And then create a new project. Example, create a new project. I will choose this try. Example, GE S7, yes. And choose the driver protocol, yes. And go first. And then we need to create the port, right? So new port number 0, right? I will change this one to 1 second. And go to device, create the new devices. Example PLC 1. Or we can write S7 1. And 192.168.0.100, right? For the CPU, yeah. This one, yes. And then click OK, and then we can update the project and then start the project. To see the status of device up And then we will create the VCC flexible to start and stop and show the signal with the simplicity, right? So let's check the device. Okay, right now device is up, so we can create the new text, right, for start and stop. Example here, we can use parallel with start. Example start HMI. It means start from the simplicity, and we can create one more and see contact for stop HMI, and we can create the %M. Create the %M also, and then save the project and then download the logic to the CPE. Okay, so start %M2, right? So let's go to points tab and then create the new text. Example start HMI. So I will choose device and then choose the boolean because it is on and off, and %M2, right? This button, and one more for stop, right? So we can duplicate and change to %M3, this one, and then we can use the %M1 also to show the status from the PLC S7300, right? Example S7 status. So %M1. Okay, and then we can create the screen. Yeah, go to new screen. I will insert the motor or pump one. Yes, example, I will create the pump one or motor one. Yes, let's see the motor one. Okay, we can change to motor one. Okay, then we can go to the button. Example, this one for stop. So color should be red, right? And copy one more for start. It is the green, right? Start, or blue. And the status of the motor, right? So we can use status, the motor is like this. So we can go to color animation, right? So we can browse the point as event status, right? Okay, and then change this one to fill to green. So if the event status is send signal, it will show green. If not send, it will show red, right? Okay, and then I will choose the string example motor 1, change to be color, sorry, this color, and for font I will use the Tacoma bold and then 18, or we can increase a bit. Okay, like this. And we can save the screen, example screen 1. Okay, and then we can simulation, yes. Right now the motor stator is turned on, right? Okay. And then we can configure the button also for start and stop. So this one should be even. Go to the mount up, new procedure, new absolute set point, the start, right? Start HMI to 0. And one more for mount down. Absolute set point, start HMI to 1, right? And for sorry, this one should be stop. Confused because it is the stop button, right? So stop HMI. And this one stop HMI also. And one more for start. We can go to event again. Choose the mount up, new procedure, new absolute set point, and then choose the start. Choose the new mount down, new procedure, new absolute set point, and then choose the point start and change to 1, right? On. And save the screen again. And then we can simulation again. Okay. So if I push stop, it will stop. I push start, it will start. Okay. And we need to create the project of WinCC flexible also, right? To show the status of motor. Example, we have if we have HMI, so we can show the HMI also when the GE PLC is transfer signal data from this button. Okay. So let's go to the schematic. I will choose this one, the same as the previous video. And then go to connection. Yes, example GE S7. And I will choose the Ethernet. So this is the IP address of computer, right? So 192.168.0.253, right? So let me check to confirm again for my PLC, my PC address. So 192.168.0.253. That's correct. And for the IP address of PLC S300 is 192.168.0.1. Okay. And then we will create the text for show the status, right? Here. So Q 0.0 is the status. Yes. Or Q 136.0 is the status from GE, right? Or we can write I 0.0 also, yeah, the same. Go to the text and add example GE data bit 1. So it is the boolean, right? And I 0.0. Yes. And can go to the screen. I will change the screen to, okay, we can use the color. And we can go to see the status of the motor also, right? Go to graph and then insert the motor. Okay, let's go to find the motor or pump, yes, that we want. Example, we can use the motor, yes, here. Big motor, right? Okay. Then I will go to the object again and choose the text file. Example, status motor from PLC GE. Go to property, go to layout, and then uncheck this font so we can change font to be 24, yes. Okay. I will use bold. Okay, and then I will change the color to be yellow or blue. Okay, and then I will copy format this one for motor 1. Okay, for motor 1. And for the status, I will use the rectangle also. The same as the PLC GE, right? The GE faceplate. So I will change to red color and then go to color animation, yeah, to change. If the status is changed from the PLC GE, right? So bit 1, go to here, and if the value is 1, should be change the background to be green, right? Then we can save the project and we can go to desktop. Okay, make with the HMI example GE S7 part 1. Okay, and then we can simulation, yes. Okay, so if I pull button start from the simplicity, yes, screen, start. Let's see the signal on the PLC S7-300 is changed also, yes, the logic is work correctly, yes. So if I push stop or if I push start stop from the hardware button, let me show. So if I push button start here. Yes. Let's see the status on the screen work also, and the output on PLC S7 is turned on also. So if I push start, if I push stop, it will stop. Start again, it will start again, right? So the communication between Profibus Master here and Profibus Slave here is work correctly. But here is very important, should be select to off, and this one should be select to off also. Yes. Okay. So this is the part 1 about how to link the data from PLC S7-300 to PLC GE by using the Profibus Slave and Master. Yes, made together. And I will have the part 2 also about link the analog. Yes. The part 1 is only digital, and for the part 2 I will link more for analog signal. Example, we can set point from PLC S7-300 and got data on the PLC GE. Yes, so we can do also. So this is very important if we have many signal that would like to link from PLC GE to PLC S7-300 or PLC S7-300 to PLC GE. So we just run only one cable, Profibus cable, so we can link, yeah, and then we can control the process by using only one cable of Profibus. Okay, so this is a benefit of link between Profibus Master and Slave from PLC S7-300 to GE. Okay, so thank you very much for watching my video, and I will have part 2 also. Yeah, so please follow up for me. So in this time, I would like to say thank you very much again, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.